Welcome to The Explainer, where today we're tackling an absolute core concept in software engineering. Seriously, this is the secret to readable, low-maintenance code, designing modules that do one thing and do it remarkably well. Have you ever opened a class, let's say it's named something super straightforward like UserManager, and you're expecting to just see methods for user registration or maybe profile edits, but instead you are hit with an absolute wall of code that formats HTML templates, parses CSV files, and writes raw SQL queries? Yeah, it's a total nightmare. Well, today we're exploring why mastering high cohesion is your absolute best defense against that exact kind of chaos.
Okay, let's take a quick look at our roadmap for today. We're going to cover 1. The junk drawer problem. 2. What is high cohesion? 3. Seeing cohesion breakdown. 4. Balancing cohesion and coupling. And finally, number 5. Rules for clean boundaries. Let's jump right in. Section 1. The junk drawer problem. To viscerally understand our core concept today, I actually want you to step away from the keyboard for just a second and picture your kitchen at home.
Think about your silverware drawer. It's got forks, knives, spoons, right? All of these items are tools used for eating. They naturally belong together, making it a highly cohesive space. Now contrast that with your junk drawer. You know the one, we all have it. It contains your spare keys, random AA batteries, a rubber band, takeout menus, and, I don't know, maybe a screwdriver. That is low cohesion. Trying to find a specific key in that junk drawer is incredibly slow and frustrating. Even worse, tossing a new takeout menu in there might completely bury the batteries you desperately need. In software engineering, we absolutely want to avoid building these junk drawer classes, because unexpected chaos is exactly what follows.
Section 2. What is high cohesion? Let's see how this kitchen analogy translates directly into formal computer science, because understanding this lets us spot these junk drawers way before they ever reach production.
So the crucial point here is that high cohesion is really a measure of relationships. It means every single piece inside your module, the methods, the variables, the whole shebang, absolutely belongs together to focus on one well-defined task. If a module has low cohesion, it's essentially juggling unrelated tasks like, say, handling database operations while simultaneously formatting user interface strings. High cohesion, on the other hand, means a singular, tightly unified purpose.
And look, this isn't just some abstract academic theory. High cohesion is actually the powerful driving force behind major industry guidelines that you probably use every day. It's the foundation of the single responsibility principle, which dictates a class should have one and only one reason to change. It powers the interface segregation principle, advising us to create thin, cohesive interfaces rather than these fat general-purpose ones. And it sits right at the heart of the GRASP information expert pattern, naturally keeping your data and the behaviors that act on that data tightly bound together.
Section 3. Seeing cohesion break down. Now that we know what this foundational core concept actually is, let's look at the real-world pain of what happens when we completely ignore it in a production environment.
Picture this. Imagine a monolithic payment gateway class that has ballooned to 1,500 lines of code. It handles literally everything: payment processing, invoice generation, bank reconciliation, even fraud detection scoring. It is the ultimate junk drawer. Because it was a junk drawer, a routine update turned into an absolute disaster. A developer was asked to update the layout of the invoice footer. Simple, right? Well, they made a tiny, undetected syntax error on the PDF styling. Because all these responsibilities were crammed into one single class, that minor PDF styling error completely crashed the critical nighttime bank reconciliation cron job. No way, right? But this proves exactly why low cohesion causes frequent, dangerous regressions. It also destroys reusability. You can't just import the logging logic without bringing the massive database and email configurations along for the ride. And finally, it skyrockets cognitive load. It forces your developers to parse through SMTP email noise just to understand core database operations. Let's look at another classic backend scenario, a single customer service coordinator class that takes on totally unrelated responsibilities. It's persisting data to the database, it's firing off SMTP emails, and it's writing to the file system for auditing, meaning a simple HTML email tweak forces you to modify the entire class, risking a massive break to your core customer registration pipeline. The simple remedy here? Delegation. You absolutely must split that email and audit logic into their own specialized, highly cohesive modules. By separating these concerns, you instantly increase reusability, you make testing infinitely easier, and you lower your cognitive load because you are only ever looking at the code that matters for the specific task at hand. Now, I love this quote.
Uncle Bob defines class-level cohesion incredibly concisely. He calls it a class in which each variable is used by each method. It's a strict, clear benchmark for your variables and methods. It actually gives you a mathematical way to look at your code and ask, are these pieces actually talking to each other, or are they just awkwardly living in the same house?
For instance, if we look at a user session manager that squashes core authentication logic right alongside user preferences like theme and font size variables, it blatantly violates Uncle Bob's rule. Why? Because the authenticate or isTokenExpired methods never actually interact with the theme or font size variables. They are two distinct business concepts living in one file. The fix is to split the class into two cohesive units that actually match your real business domain.
Section 4. Balancing cohesion and coupling. But hey, before we go rushing off to split every single class in our codebase into a million tiny pieces, we really need to look under the hood at the architectural trade-offs.
You are constantly balancing on a tightrope here. On one extreme, you have a system composed of a single massive class that does everything. It has zero coupling because, well, there are no other modules to connect to, but it has zero cohesion because it's a complete mess. On the other extreme, you have an exploded network of thousands of tiny, single-line functions that are perfectly cohesive but impossibly tangled together, leading to completely unmanageable coupling.
The ultimate goal of your software architecture is to gracefully balance these two opposing forces. You want to group elements that change for the same reasons together, that is, your high cohesion. At the same time, you want to minimize the dependencies and the communication required between those separate groups, that's your low coupling. It is all about drawing boundaries that actually make sense.
Section 5. Rules for clean boundaries. Let's move to the practical takeaways, giving you a concrete methodology for maintaining these highly cohesive modules without accidentally over-engineering your entire codebase and making it impossible to navigate. By following these 4 steps, you can strike that perfect balance. First, apply the variable method test. If a group of methods only operates on a tiny subset of variables, extract them. Second, balance with complexity. Remember the more is more complex principle. Don't split up a simple 50-line class just for the sake of it if it functionally makes sense as one unit. Third, align with the model principle. Your cohesive classes should match real business objects like email service rather than generic, abstract nightmares like logic processor. And fourth, just accept that some low cohesion is inevitable. Facade classes or application bootstrappers naturally wire a lot of unrelated components together, and that's fine, as long as you isolate them and ensure they contain absolutely zero real business logic. When we rate the practical impact of this core concept, it is truly outstanding. Earning an overall A- grade or an 8.3 out of 10, High Cohesion has a 10 out of 10 for cross-platform relevance. It applies everywhere: class design, microservices, database modeling, you name it. And with a 9 out of 10 for real-world impact, it is the absolute primary defense against spaghetti code and compile time bottlenecks in large-scale applications. It ensures your classes remain small, easy to test, and perfectly safe to extend. As we wrap up this explainer, I want to leave you with a final thought to really challenge your own codebase. Think about the file you edit the most. If you opened it right now, are you looking at a beautifully organized set of silverware with a single, clear purpose? Or are you staring into a junk drawer, just waiting for the next takeout menu you toss in to break the entire system? Go take a look and start drawing those clean boundaries.